So, main question is that what's the physical? It's the physical, okay? Meaning of convolution. It's a summary part for our case, okay? So, firstly, convolution is a unique picture, okay? What's the meaning of the unique? Tell me. Yes. Representing unique things, such as system, model, man, Hakan, and also Ayça, or any other object, regardless of time dependent or not, okay? In the second conclusion is that it is actually a geometrical root, okay? Just like x1 x2 is equal 0, right? This is the independent feature of the R system, but it is what is the shape of the what R geometry. And so if we are using the x1 and x2 to represent the one thing in here, for example pen, or the what, the computer, this convolution or the one template pattern is used as the what, the geometrical root. In the first place, we talk about these things, but these things is a unique thing, and it's the time independent parameter. But if we are using the convolution, and so we can create the pattern to represent one thing, just bara, right? This is a body, and so this is the impulse signal, but in 2 dimension or 3 dimension, right? And so this is a unique thing. Just the geometrical root looks like that, İlayda, right? You understand that? Okay. But in the signal form, x minus x1 times x minus x2, we don't have this feature because it's the 2 instant value it's given in here for one time, instant time. But if we have this property in here, we can integrate the whole signal or the button, and then we can yield to the what, to the human definition, right? It's just like the Euler identity geometry, right? And so if we have the what, E over I times pi plus 1 is equal to 0. This is the Euler identity. And so we know that we have a circle, perfect circle in here. And so this circle is actually what? It's the impulse picture of frequency, right? This is the picture of the frequency. And so if we integrate the any function by using the Euler identity, and then we can take or generate the what? Frequency. Just like button. I can integrate you, and İlayda, and so I can say that all things are concerning about what? The human. Okay? And so I can generate the templates or the impulse function to represent what? To represent anything. But the Fourier is the most beautiful, it's created most beautiful formula for the what? For the frequency, right? It's unique in math, but we can define any system based on this information in the time domain, right? And so if we generate a specific convolutional pattern, and then we can build, or we can estimate, or we can define, or we can establish to what? To any signal. But this signal is the desired signal, right? For example, if you apply a voltage to the what? To the DC motor, and then we will take the what? The position or the velocity at the rotor. And so this velocity or the position represents to the what? The YT. And then the DC motor has the specific impulse function, right? So if we apply the input, and then we will take the what? The YT. But these things is produced with the what? With the convolution of the DC motor and the input. Otherwise, we cannot apply, or we cannot take this parameter. Don't you agree with me, İlayda? Yes? Hakan? What do you say? Am I right? Okay. I don't ask anything about that. And so, yes?
If we need to combine more than each other, we use convolutional operation to combine them to get a way to sample the phenomena or anything using that.
Please ask me in Turkish. Please ask me in Turkish.
Okay. Şu anda bu feature'ları bir şekilde temsil etmek istiyoruz.
Yes.
Sampling yapabilmemiz için tek bir feature'a combine etmek istiyoruz.
Yes. So ADC, for example, has a specific, unique impulse function, right? So also you have an impulse function to understand anything coming from the universe to you, okay? So in the tree for the roots, we have the what? Just remember that this is x3, x1 and x2, and so we can build what? A cube in here with the formula of the what? Equalization of the zero, right? But in the convolution we have this kind of pattern xt in here, and so if we have xt in here with the pattern of these terms, and so we can build also what? The impulse signal, just like this one, okay? And so what about the output of this term? Ayça, can you help me to write this signal? Okay. And so just remember the integral. We need to shift to what? The ht, okay? And so we have this parameter in here and this parameter in here in the shifting form, right? We have 1 square, 2 square, 3 square and 4 square, and so at each time we can shift this square with the what? The right hand side, okay? And so in this domain we have the what? The zero, because there is no match pattern in here, right? Because this square cannot intersect with the xt one, right? And so after that we can iterate this square to the what? To the right, right? And so this is increased in linear one, right? And so, but in one case we have the what? The complete match in here, right? This is the maximum value. And so if we are iterate this ht from the right hand side of this square, and so we have this kind of information, and then we have this pattern here, right? And so for example, at the 3 is equal to 3, t is equal to 3, and then we will have the maximum pattern in here. For example, I have a brain, and so my brain have the many impulses about the human, and so what time is that? 2.12, and so I can see the baron, okay? And so t is equal to what? 2.12 minutes, and then baron is highest value, just like this one, right? But it's not the time that affects my imagination. I also search to what? 3 dimension, right? X, Y, and Z, right? And so if I turn my head to right, and so the baron, what? Is diminished, right? This is just like this term, but this is the 1-dimensional data, okay? I can see the LiDAR in here with the value of the convolution of the what? The 1. But if I change my head, and so the Emre is 1 and Elida is 0.01, and so if I change my head, and so the Ayça is 1 right now, okay? In 3D dimension and at the what? The time domain, and so we have 4 dimensions in real life to convolve anything, okay? Do you understand that? So if this is the case, I can define the Mehmet pattern, right? Just like this one. This could be Mehmet, okay? Or I can define the Hakan pattern, just like this one, okay? This is the time relation or time dependent pattern for the what? For the Mehmet or Hakan, okay? Because in real life we always see or emulate or perceive the objects just like Hakan to what? In time dependent, right? In order to analyze or get the whole feature of these terms in the Hakan, and so I will look at you. For example, up to 1 minute or the 5 minutes, right? And so you have the specific convolution in my head, which I know you. You're a good person, a hardworking person, but Ayça is not. Okay. So, any question? No. Time is always going forward, right? We cannot make otherwise happen, right? But if I see you in here, and so the time is going, so 1, 2, 3, 4, but I see you in 3D dimension, right? You have an X dimension, Y dimension, and Z dimension, and so if I see you at the what? The X equals 0, Y equals 0, and Z equals 0. But if I change my perspective in here, just like this one, the Ayça at the position of the what? The X 5, Y 5, and Z 0. Okay? And so we need to apply the what? The 4-dimensional integral in here. dx, dy, dz, and d tau. Okay? No, everything is changing, but the one of them is the what? 1, 2, 3, 4, and so the x tau times h tau t1, h2 t tau, h3 t tau 3, and ht tau t4, d tau 1, d tau 2, d tau 3, and d tau 4. These are the basic perception of the universe, but this t is indicating with the time, but the other terms t, t, t, this is the position of yours, x, y, and z in 3D dimension. Okay, this is the integral of the what, the how I look you in my brain. Okay, that's the case. You get it right now? Okay. Tau is the arbitrary number, because the tau just like this one. If I choose the what, the tau is 0, tau 1, tau 3, tau 2, tau 4, 5, 6, 7, 8, 9, 10, 11, blah blah blah up to infinity. Okay, this is tau. I search the area, arbitrary, and so if I choose the 1, 2, 3, 4, 5, 6, 5, and so 1, 2, 3, 0, and minus 1, blah blah blah blah, and minus infinity. Okay. Yes, this is are the perceptions. Okay, and so if increase the highest value in here for your concept, and so I can define you in my brain. I can imagine, or I can see in the 3D or 3 dimension. Okay. Okay. Dish. Yes. Yes. Yes, x, y, z, and t always going to what? Infinity, right? And so this is Ayça, and so this is İlayda, and this is mine, Mehmet. So I can see that this picture in here, right? And so if I change this time, tau 1 or tau 2 is increased at one direction or the another dimension. Okay, so the Emre is in here. So it's the basic case for the convolution. Okay, do you understand the convolution? You understand the real meaning of the convolution? It's important. So if we have this information, and then we can define a linear time invariant system. It's the basic topic of this lesson, right? And so section 3, linear time invariant system. What's the meaning of this? Have you heard of the LTI system up to now? Hakan, have you heard of it? Okay, what's the meaning? What's the linear time invariant system? How can I define it?
Şöyle, zamanla lineer bir şekilde değişen sistemler.
Yes, but for example, is İlayda is linear time invariant person? Is Emre?
Değiller zamanda.
Why?
Aynen bu yüzden değiller.
Why?
Yarının durumlarını, dünkü durumlarını.
Yes, we are getting old, right? For example, I have an age different of yours, right? And so at each time, the time changes the people, like yoga, right? Okay, and so the linear time invariant or time invariant means that we couldn't change the parameters or the system parameters or the distinct features of this system with the time, or this is time independent distinct feature which is given in here. For example, in simple meaning, y dot is equal to what? Minus 5y. This is time invariant or not?
If y is not a function of time, it is time invariant.
Time invariant or time variant?
If y is a function of time.
Yes. No, it's not about these things. This is time invariant or not? Please tell me.
If t doesn't affect the result, the equation, it is time invariant. If time doesn't affect.
No. What is the system equation of this term? What's the main characteristic coming from this system? This is linear and this is also linear, and so the R model coming from these coefficients, just like the second root, ax squared plus bx plus c is equal to 0. Okay, and so we have constant root, right? And so this is constant, and so this is the time invariant system. But this system evolves in time because the y dot is a derivative term, right? But if I choose the what sin t times y, this is time invariant or not? Why? Yes. Okay. Y dot at times y. This is time invariant or not? Okay. Y dot minus 5 yt square or y square. This is time invariant or not?
Not linear, but it's time invariant. But
Time invariant or not? No.
if y is not a function of t, time, it is time invariant.
Yes. Okay. And so this is non-linear time invariant. Or y dot is equal to what? Minus 5 yt times y. Right? This is can be considered as a time invariant or linear time invariant in here. But if I choose the parameter of the minus 5, and so this is a non-linear time invariant system. Otherwise, we have the linear time variant system, right? Linear time variant, but this is the non-linear time invariant system.
Actually, I have a question. Minus 5y, it will be multiplied by y, so it is y squared. Y, it is linear.
Yes.
It can be non-linear. It is not
No, in the first place, we take this parameter as the non-linear one. But in the last one, we can say what this is the system parameter in here with our definition. Okay, if this is the definition, and so we can say that this is the linear time variant system, just like the AT. Consider this AT is equal to the what? Minus 5 yt. Okay.
At the end of the day, it is y squared.
Yes.
Anyway, it is y squared, so it is not linear. This is my question.
We cannot evaluate this condition. Otherwise, we don't have any function in here. Just see that this is the maybe coefficients of the system. We can say that it's our definition. Okay.
But coefficient is affects the system as like as
Also,
the terms.
in that case, we don't need to define the R system as a time invariant or the variant. In your case, we don't have any definition in here, right?
We have actually.
No. Because at the right hand side, everything is equal, and so, but if we apply some theoretical rules on this parameter, and so we need to define the sum definition in here, just like this one.
So if we assume this is a coefficient of the equation or of the term, this coefficient is changed by time. So it is what I understand from the coefficient is a like fixed number, so we can control the equation.
No, we can manipulate the equation in the what in order to get the proper form for us to solve easily this problem. And so we can define the linear time invariant or the variant system based on the R definition, just like this one. We can say that we can define the AT as equal to what? Minus 5 times Y. Okay? And so this maybe generates or enable us to what? To solve this question easily.
So it depends on what system we are trying to control or what system we are trying to.
If you permit me, I will explain everything in here, because if your question about that, I don't understand your points or the problem about that. Okay, because I can define this function in any form in here, just like this one. Okay, so in the convolution, every time-dependent system has unique property or the shape of the convolution. Okay, just like the roots. For example, Baran has the 2 roots. One represents to what? The length of the Baran, and the other term is the mass of the Baran or the weight of the Baran. Okay, we can define the Baran based on this information. Okay, just like this formation, and so we can use the convolution to create a time pattern, which we call it to the what? Impulse response or the impulse template signal, right? But in order to do that, we should define the theorem for dot 3, which is the basic notion about the signal and processing or signal systems, which we call it the Dirac delta function. Have you heard of it? Dirac delta function can be thought of as a function of the real line which is 0 everywhere except the origin or the present, where it is infinite. Okay, which means that this is what plus infinity value t equals 0 and 0 t not equal 0, and also we have the property of the what? Minus infinity to infinity value dt is equal to what? 1. This is what? This is called the Dirac delta function. Okay, with the same analogy, we can also say that if we are using this term with an index, discrete index in here, just like this one, 1, n is equal to 0, 0, n is not equal to 0. This is what? Unit impulse function in discrete domain. Okay, for all n, these two things are identical, but one of them is independent of the time, the other one is not. It's dependent of the time, because one of them is continuous, the other term is the what? Discrete, right? And so if we are dealing with the what? With the discrete signal, we need to use the unit impulse function. But if we are dealing with the what? The continuous function or signals, and then we need to utilize the Dirac delta function. Okay, And so this is Dirac delta function t, and so h t, right? And then the Dirac delta function looks like that. The area under this term is equal to the what? The 1, or this one, or this one, or this one, right? And so we just only see that the unit circle of this term is equal to the 1. This is the important property, because if we have the 1 point, the t is equal to the 0, and so we have also area in here in the continuous domain, because the Pythagorean theorem say that if we convolve or if we interact with any other function or any other continuous domain, we need to what? Area, nothing more. But in a discrete domain, we take the one sample, and so we can use the what? This notion, just like this one. It's the 1 and 0, and so this is the hn to characterize this system. The first one is the continuous, and the another one is the what? Is a discrete one, right? And so we have the what? The area must be equal to the 1, and so we don't need to what? Area in this form, because we have the sample already in here. So what's the meaning of this area is equal to the 1? Have you heard of this? Have you heard of these things or this property in the another mathematical science, which this function area is equal to the what? To the 1. Area is equal to 1, and so which area or the topic of the maths are? Yes, this is the what? The probability theory, right? What's the similarity between the probability of and the Dirac delta function? Why we always contains to what? To 1 or 100% for a given probability? Why we don't have the 150% probability? Why we don't have these things? Because it's nonsense, right? If we have the 100% or the area is equal to the 1, and so these events always happen, right? And so this Dirac delta function is the interaction between the what? The probability rate of any events in the time domain, okay? And so this is highly utilized in the what? In the quantum mechanics, or the Schrödinger equation, or the any other form of the what? The modern physics. If this is equal to the 1, this impulse response, and so these events must happen just like the what? The system response in the universe. But if I choose the Dirac delta function with the different area rates, and so this is called to the what? Quantum mechanics. Okay, and so this is the case. If this is the case, for example, if we have the one-dimensional data in discrete domain, and we can multiply with the 1, and so we get the x, okay? But this is the discrete one. And so if we sample any signal in the microprocessor, and then if we are using this impulse, and so we take the values, and the x is, for example, 5, and so we get 5, okay? But in real life we don't do this, because everything is continuous based on the Bernoulli theory, right? And so we should always take this integral just like this one, okay? D tau. So this is the integral form of these terms. this integral maybe is a system in here. For example, just remember that we have the what y dot is equal to the what minus 5y plus u. This is the dynamic system, or this is, for example, is the first order system in real life. For example, this is the motor equation, DC motor equation, and it's the dynamics. And so if this is the linear and time invariant system, and then we can obtain this formula based on the what, this one, system, and blah blah blah blah blah, and system. Okay, just remember the control lesson. You can generate the output of this term yt for a given what, for a given input, right? If it give the voltage to the motor, and so we get the theta value, position value, or the velocity value, or the y value. Okay, but if this system is linear, and then we can formulate this system based on these concepts: t minus 0, t minus 1, t minus tau. And so if this system has unique pattern, and then at each step, if we apply the impulse response, we have the yt signal. For example, if we have the DC motor just like this one, and so if we apply the infinite impulse response, t1, t2, blah blah blah, and so t tau or n, and so we get the theta or theta dot value, because the DC motor has the unique pattern in the time domain with the impulse response, right? And so we can build this combination in the what, in this form, because just remember that if we model these things just like this one, and so we can feed the xs in here, and we can take ys in the transfer function domain, right? And so this is the hs, and so we can write this system, this one hs is equal to what, the ys and xs, right? Okay, and so we can define ys is equal to what, the hs times xs, or in time domain, just remember that how can I write this formula in time domain? Yes, ht star or convolutional operator times xt, right? And so if we have the DC motor, we have the one impulse pattern related to this system, which is calling to what, the h, and so h defines to what, the dynamic relation between with the what, with the convolution. And then if we apply the xt, and so we will get the what, theta or theta dot. But if this is true, with the what, Dirac delta function area must be equal to the 1. And if I choose the Dirac delta function is equal to what, 0.8, and so I will have different output, like in quantum mechanics. Okay? Okay, see, if we have the system hs, for example 1s plus 5, okay, and so we can apply the impulse response, impulse unit function to this one in the MATLAB. Have you remembered that, this notion? If you have you used the impulse response in the MATLAB? You use? Everyone use? Okay. And so this generates just kind of signal in HD. Okay? And so this is what? This is the basic definition of 1 divided by s plus 5. Okay? Or we can generate the what? This kind of ht. And so this ht at each time under the output we can convert this signal based on this one. This is, for example, 1 divided by s plus 5 ht. And so if you have the what unit step applied to this signal, and then we will have the what, the output just like this one. At each time we convolve this pattern with the what, with the one value or the area of this term. Okay? And so the convolution of this term based on these things generates the what, this output in here. Okay? This is the output of these terms. And so this is the what, 1 divided by s plus 5. Okay? These are convolved pattern to define the R system. And so we convolve this system based on the what, this term ht ut multiply ht minus tau divided by tau yield us this dynamics. Okay, at each case. And so how can we write the example of this term? For example, if we have the mass value in here just like this one, okay, and so we have the B, the friction force in here, M, and xt is equal to what, the Ft in here, okay, and so we have the dynamic equation of these terms. F is equal to what, M V dot plus B V, right? This is the equation of motion of these terms, okay. And so in transfer function domain, how can I write these terms? Fs is equal to ms v s plus b v s, right? This is our function, right? And so this can be reorganized in this form, vs divided by fs, which is hs is equal to what, 1 divided by ms plus b, right? Or it's equal to what, 1 divided by m s plus b divided by m. Okay, and so this hs represents to what, the transfer function of these terms, right? And so this is our system in frequency domain. But what is our impulse response or impulse function in here? Vt is equal to what, 1 divided by m times exponential term 1 bt, right? This is the ht. This is the template pattern for this mass damper system. And so either we can use this function to convolve with any input, or either we can use to what, the transfer function to solve this system, right? And so if this is the case, we can take the output of Vt, which is equal to what, the minus infinity to infinity values, f tau, this is the force value coming from the output input h t minus tau d tau, and so minus infinity to infinity value f tau times what, 1 divided by m e b m t minus tau, right? The tau yields the R results of this equation. And so if we take these derivative values, or if we take this integral value or convolutional pattern, and so we will have the what, the velocity value of these terms. Okay, any question? Okay, so we have a reminder section in here. Tamam. Reminder. We have the pattern for fs, for Laplace ft, right? 0 to infinity value ft times e st times dt, right? And so in this case we have a convolutional pattern. Which one is the convolution or this impulse pattern in here? Huh? Yes, this is the impulse of what? No. Impulse of what? Frequency, right? And so this is the shape of, this is the function of the frequency, right? And so with the same idea we can write also just these things. 2 pi f is equal to what? Minus infinity to infinity value ft, and so e j wt dt, right? And so this is what? The Fourier transform, right? And so this is also a what? Impulse of frequency. But this is which kind of frequency? Oscillation frequency, right? Because in this pattern we have the signal like the decay or growth, right? We can diminish the whole energy based on this form, but in this form we cannot do that. We always oscillate, right? In the Fourier transform, right? Okay. And so this is the impulse, and so what it is look like? Real and imaginary, right? But in the convolutional pattern we have only one thing, ht, right? This circle is only contained in the what? In the real physical identity, right? Right? This function contains only one quarter circle in here. But if I use the imaginary and the real part, and then we can multiply this area 1, 2, 3, 4, and so we can create the frequency in here, just like this one, right? Because if we have this pattern only contains with the what? With the one semicircle in here, as quarter circle in here. But if I choose these things in two-dimensional form, and so we can generate a frequency pattern, right?